Hello there. This is Trigonometry Chapter 1, Section 1.3. Got a little video for you to go through the notes. Very easy day on this. Won't take too long. It is early in the semester, so it's pretty quick. So a lot of this, let me move my picture over here. There we go. You can see me. A lot of this particular stuff you've seen before. So you guys have definitely seen sine, cosine, and tangent. So you guys have definitely seen, oops, there we go. Sine, cosine, and tangent. There's no question you've seen that. Okay. And then you've seen their co-functions, cosine or cosecant, secant, and cotangent, the inverse of that. Okay. And if you're looking from this angle's perspective, right? From this particular angle's perspective, you got the opposite, adjacent, and you got the hypotenuse. Okay, so most of this is stuff you've definitely done before. So this is going to be pretty quick. So you're pretty quick to get these notes done, and then you can jump into your homework and jump into your other practice that you have to do. Okay? All right. So in this case, let me write this out a little bit. I don't like how this is written right here. This is 2 radical 10, right? Because this is 7 squared is 49. 9 squared is 9. And then 49 minus 9 is 40. 40 is 4 times 10, so it's 2 rad 10. So if you remember your radicals. So alpha, they'll use alpha and they'll use theta for angles. Doesn't really matter. So this particular angle right here is our alpha right here. Okay. The sine of that is opposite 3 over adjacent, which is 7. No problem there. That's got to be like incredibly simple. Okay, I'm going to rewrite this again for you. Okay. All right, I'm going to make this 2 radical 10 permanently. All right, there we go. The cosine of alpha, right there, the cosine of alpha, and there's alpha. That would be the adjacent 2 rad 10 over the hypotenuse of 7, no problem. Now, I did not rationalize the denominator. There's debate on whether you really need to do that. I didn't for the purposes of this notes because I didn't want to get into a separate skill. I wanted to keep it really simple. The tangent of alpha, tangent is opposite over adjacent. So that's 3 over 2 rad 10, as you can see right there. Okay. The secant of alpha, the secant of alpha, you can let's see here. Slice this a little bit. There we go. The secant of alpha is hypotenuse over opposite. So here we go. The hypotenuse of 7 over the opposite 3. It's just the inverse of the sine. Okay. And then the secant of alpha, 7 over 7 rad 2. Excuse me, 7 over 2 rad 10, no problem there. And the cotangent of alpha, cotangent will be adjacent over hypotenuse, as you can see right here. Okay. Cotangent of alpha. And that'll be 2 rad 10 over 3. Okay. And then we got another angle down here. Let me erase all this. Most of this you can walk through yourself. It's really, really, really simple. There's not much to this. Okay. So here we go. Now on this one, this is radical. Whoops. This is radical 39. Okay. Because that's 64 minus 25. And then you get radical 39. All right. And the sine of B. And here is beta. This angle is what we're talking about. Sine is opposite over hypotenuse, 5 over 8, no problem there. Cosine of B is adjacent, which is rad 39 over 8, no problem there. Tangent of B is opposite, 5 over adjacent rad 39. And again, I didn't take out I didn't rationalize the denominator. I'm not worried about that right now. The cosecant of B, the cosecant is the inverse of sine. So if the sine is 5/8 right above it, then the cosecant is 8/5, just inverted. Same thing here. The secant of b, that's the inverse of the cosine. If the cosine is radical 39/8, then this is 8 over radical 39. And the same thing for the tangent. Just flip those upside down to get the cotangent. Is that easy or what? That's great. Okay. So let me erase this. Okay. Now, understand and calculate with cofunctions. Okay, no problem with cofunctions there. So just so you know, the sine of like 60 is the same as the cosine of 30. It's just 90 minus. So that makes that really, really easy. Okay. And the tangent of A is the same as the cotangent of 90 minus A. Okay. Secant of A is the same as 90 minus A. And then you got these as well. By the way, the sine of A, sine and cosine add up to 90. Okay. So all of these are just boilerplate stuff. So let's do these. So the sine of 51 is the same as the cosine of 90 minus 51, and hence 39. The cotangent of 43 is the same as the tangent of 90 minus 43, which is 47. Cosecant of x is the same as the cosecant of 90 minus x. That doesn't make a new number in this case, just makes a phrase, 90 minus x. Same as this one. This comes out like this first, 90 minus x plus y. And then you have to distribute the negative to both of these, and you end up with this answer right here. Okay. Same here. This is 90 minus parentheses 50 plus m. Okay. So 90 minus 50 is 40 right there, and then it's negative m. So there you go. This is the same thing. 90 minus 35 minus k. Now you're going to distribute that negative. So 90 minus 35, the first part is 55, and then negative k is positive k. Okay. That's pretty easy lesson. That is, again, early in the school year, it's supposed to be simple. That way you can get to your other work and get to your practice, because we have a lot of review skills to do so that you're all up to date and you're ready to go. And things get a little harder. This is to be expected. Okay. That is 1.3 in chapter 1 of trigonometry. All right. We'll see you.